Hello everyone and welcome to this video. So in this video we'll continue writing our TFX pipeline and then we'll run that pipeline in Vertex AI. So in the first video we looked at ExampleGen, which injects data into TFX pipelines and also does the splitting. And in this video we will look at StatisticsGen, which generates feature statistics over both training and service data. We also look at SchemaGen, which creates schema by inferring types, categories, and ranges from the training data. And then we will also look at the example validator, which identifies anomalies in training and serving data, right? And then in the other videos, we will look at transform, tuner, training, evaluator, and then pusher, right? So let's go ahead and then run write some code for the next steps in our pipeline. So we'll start from here, and then the next one is the statistics gen, right? So we will say here generate statistics, right? And then we have statistics statistics gen gen is equal to so it's tfx dot components dot statistics gen, right? And statistics gen will take the output of examples gen, right? So we'll say examples, which is example gen dot outputs, and then examples, right? So that's all for statistics gen. And then we have the next component, which is schema. So generate schema, which is making so many errors today. So schema gen, and then the schema gen will take the output of statistics gens because it's a pipeline. The next component will take the output of the previous component, right? So we have schema gen, which is so it's tfx dot components dot schema gen, and then the input is statistics. So statistics gen dot output and statistics, right? And then the next component is example validator, right? So example validator, so we say identify anomalies, right? And then we have validator is exam no, so it's tfx dot components dot example validator. So example validator, and then example validator takes, if you can see from the graph here, from the figure here, it takes the input of schema gen, right, and then statistics gen also, right? So this arrow goes down from statistics gen to example validator. So we have to so here we say statistics is statistics gen dot output statistics, and then we also have the schema which is schema is SchemaGen dot output schema, right? And so that's how we are done with our three components. All we have to do is now add the three components to our list, right? So you can initialize an empty list and then do components dot append. I just like to do it this way. And then the validator component also here. So we are done. Let me save that. And then yeah, you can go ahead and then um, run this. So I'm going to run that again. I'm not going to create my buckets because I've already created them. And then I'm going to run this line again. So there is an error. So it's SchemaGen dot output schema. Right. Let me make sure that StatisticsGen dot output ExampleGen dot output example SchemaGen output schema. All right. So run that and then run this, and then let's submit the job to Vertex AI, right? So we go back here. When we refresh, we can see that the job has been submitted. It's running. You can also see our previous job over here. So I'm just going to pause this video and come back when when there is an update. Maybe there is an error or it has succeeded running, and then we'll check the outputs from there. And as you can see, the pipeline succeeded. It took just 6 minutes 34 seconds. So we can open up and see how it looks like. You can expand the artifact. So the CSV example gen produces the examples. StatisticsGen produces statistics. SchemaGen produces schema. Example validator then validates anomalies, right? So we can look at a summary of these components. So actually, that's not all we can do with our pipeline, right? We want to see some, let's say, output. For example, for our statistics, we want to see the statistics that was generated. For our schema, we want to see the schema, if there was some data with the schema, if there was some anomalies, we want to see that also. So how can we do that? So um, we can do that using, so when the pipeline runs, it generates some URI, right? And we can actually use that URI to see the output of our pipeline. So right, so I don't want to go through the code for this, so I've already written it in the Jupyter notebooks, which I would also share in the GitHub page. So to visualize our statistics pipeline, we have to copy this URI which is generated, right? And this URI contains some output. So we are going to visualize it using TensorFlow data validation. So I have to put my statistics URI and make sure you are just copying the whole URI. So your URI should start with GS backslash salary pipeline. If you copy this, it's just if you just click copy link, it's gonna copy link address. It's gonna copy an HTTPS link, and which is not correct. So you just have to select the whole thing and then Control C. So so this is our statistics URI pipeline, and in the directories of our GCP bucket or GCP storage, we have our split train, and then we also have our split eval data, and all of them have this feature stats BP file, right? So this is the feature stats BP file. You can look in your bucket, go to that directory or your statistics directory in your bucket, and you can find this feature stats BP file for both the split train and the split eval. So this is our link for the split eval and the split train, and you can specify what statistics we want on the left and which statistics we want on the right hand side. So after running tfdv.visualize statistics, we have this graph over here, and it shows you the statistics of what are your numeric features and what are your categorical features. And then you can see the split train and the split eval. So your age, the counts, that's the number of examples that you have or the number of samples that you have. These ones have a lot of zeros. The labels, so you can see that it's unbalanced classification. Then you also have your categorical features. So we need to transform these features when we get to the processing step. Now, the first time you run this thing, you might not see an output. So you might have to run it a second time, and then before you can get this nice looking graph. You can also visualize the schema using this code. So in the same way, you just have to click on the schema um, output over here. If you are not getting this artifact here, you just have to expand the artifact, right? So it's over here still. If you expand the artifact, you can see it clearly, and then you can just copy the URI. And so in the same way, we copy the URI. For the schema, we use the load schema text and then display schema, and then you can see all your schema over here. So for example, for education, this is the unique values we have for education, for marital status, for native country, for occupation, for race, for relationship, for sex, for work class. And then for the age, it's an int, capital gain is an int, capital loss, int, string. Yeah, so you can see how it infers the schema of your data set. We can also look at the anomalies. So if there are some anomalies in your training and then evaluation data, you can look at the documentation for how TFX calculates these anomalies. And you also have to provide the anomalies URI, and then you load and then you display. So we don't have any anomalies in our data. So yeah, so this is how you can use the TFX and then Vertex AI to run your pipeline and also visualize whatever output you are getting. I haven't found a way to display this natively in Vertex AI. I don't know if it can be done. If you know it can be done, let me know in the comments, and I will update um, the code. All right. So this is all for this video, and if we so in the next video, so let me just go ahead and then let me say TFX. So what will be the next component? So the next component will be transform. So transform, we are going to convert our categorical features. We one hot encode our categorical features. We put our numerical features in a range and change the names of our columns and things like that, right? So it's gonna be interesting, and I'll see you in the next video. So go ahead and then run this code on your own. You can provide your own data sets and then see what you get. So see you in the next video.